I welcome you all for the dairy engineering course on the topic spray drying of milk. And myself, Dr. G. Rathinam, working as Associate Professor and Head in Department of Food Technology, Hindustan College of Engineering and Technology, Coimbatore. Everyone knows about the spray drying of process. It is a drying process where the excess amount of moisture will be removed and the product will be converted into a powder. So spray drying, that is a method that produces the powder with the help of a hot air or hot gas that moves over the product, evaporates the water, and finally the product which will be converted into a powder and it can be collected in the cyclone separator. This is the spray drying process, and it is a convection drying process where hot air which can be used as a heat transfer medium. Most probably the heat sensitive foods which can be used for the spray drying process, and it is spray drying process, and mostly we are going for spray drying of milk in the commercial production purpose. Spray drying process involves atomization of the solution by either through nozzles. So the emulsion or solution or the liquid or semi-solid particles which can be sprayed in the drying chamber with the help of the nozzles that is present in the atomizer. So therefore the rapid evaporation of the droplets which will be taking place either through the hot gas which is spread over on the liquid particles that is sprayed over at a certain temperature and pressure, and it can be collected in a cyclone separator where the grades of the product will be distributed. The principle is the continuous transformation of fluid from a fluid state into a dried particulate form by spraying the feed into a hot air drying medium. The feed is either solution, slurry, emulsion, gel or paste which is provided through pump in atomized form. So the pump may be a positive displacement pump or reciprocating pump or centrifugal pump where the feed that is present in the storage tank that can be moved towards to the drying chamber through the pump. A known volume of milk can be sprayed towards to the drying chamber, and through atomizer that will be spraying, and the drying process takes place in the drying chamber. The construction, the spray dryer that is consists of feed pump, atomizer, air heater, air dispenser, drying chamber, cyclone separator, and a system for exhaust air cleaning and powder recovery and other kind of things. So it consists of a large cylindrical drying chamber with a short conical form that is made up of a glass or a stainless steel. If it is a lab scale, the glass can be used, or if it is a large scale, stainless steel can be used. So most probably stainless steel food grade can be used to avoid any kind of contamination, and that cannot be reacting with the products. So this is a schematic diagram of a spray dryer. First, the feed or liquid or any other milk or any other heat sensitive products that is pumped from the storage silo tanks towards to the drying chamber. Either the pump, the reciprocating pump or positive displacement pump or centrifugal pumps can be used for transferring the liquid from the a known volume of liquid from the storage tank towards to the drying chamber or atomizer. So the particles, the liquid particles which will be moving towards the atomizer, where the nozzles spray the liquid particles either in a coaxial flow or countercurrent flow, or coaxial flow or countercurrent flow. So the drying hot air medium which will be impinged over the sprayed liquid particles where the evaporation of the water will be taking place. Usually the hot air will be at a temperature of 90 to 120 degrees Celsius that can be dry the liquid particles that is sprayed from the atomizer, and after that the dried powder which is moves towards to the cyclone where the dust particles from the dried powder can be collected, and grade 1 particles which can be collected at the bottom. The working principle, that is the continuous unit operation where the atomization, spray air mixing and moisture evaporation and dry product separation will be taking place as I explained in the schematic diagram. So the drying process that begins with the atomization and moves towards the spray and air mixing, hot air mixing, and the evaporation of the moisture will be taking place, because when the high temperature hot air, when it reacts with the liquid particle, the movement of the moisture from the liquid will be taking place, that is inner towards to the surface and surface towards the atmosphere, and it will be moving towards to the drying chamber, and after that through the exit air facility. So the atomization, the nozzles, different kinds of nozzles will be provided. There are three different kinds of nozzles, and basically rotary atomizer can be used for the spraying of the liquid droplets or semi-solid droplets. And advantages. The spray dryer is a versatility of technology and it has a flexibility, no corrosion, no wear and no tear, and you have a correct exact feed rates and exact production of the powders, good in quality and rapid evaporation taking place, less drying time compared towards to the other. If you are using a drum dryer, the conduction type of heating can be takes place, but the quality of the product may be questionable. So it is a fully automated control system where you can continuously monitor and recording of very large number of process variables simultaneously. So you can once if you are feeding the liquid, you can get a powder as an outside because it is a fully automated control system process. It is used for both heat resistant and heat sensitive products. It have control over the particle size, bulk density, degree of crystallinity, impurities and residual solvents. It can ability to produce spherical particles with uniform size and also it reduces the bulk density of the product. So if it has creates more surface area so that it can easily packable and easily storable for a longer time. The powder quality remains constant during the entire run of the dryer. And disadvantages, the cost of equipment is a major disadvantage as the initial investment is higher. The overall thermal efficiency is low. Thus, large volumes of heat is wasted pass through the chamber without contacting a particle. Because whenever spraying, only a 40 to 50 percentage of sometimes a 40 to 50 percentage of the air may contact the spray dried particles and remaining 50 percentage air gets wasted. Hence, the energy consumption point of view, it is quite a bigger disadvantage. And also the thermal efficiency. The thermal efficiency indicates the air which is going outside through exit air may contain some amount of heat. So that heat can be recycled and it can be utilized for the further pre heat treatment to reduce the moisture from 80 percentage to at least 60 or 50 percentage, and so that the spray drying process will be still more efficient and the energy consumption point of view it also more efficient. It is difficult to maintain and clean after use, and product degradation or fire hazard may result from the product deposit in the drying chamber. And application mainly it is used in the dairy industry, mainly for the milk powder, juice powders production, and most of the spray drying which is implemented for the milk powder production and sometimes for the encapsulation purpose either micro or nano, and in pharmaceutical and biochemical products, and also in the egg powder preparation, egg white powder preparation, egg yolk powder preparation, and the fruits, vegetables, purees, and carbohydrates, and any other meat products, etc. So thank you for the patience listening. This is all about the spray drying, working principle, construction, and other details. We'll see in the next video. Thank you.